Alright everyone, welcome back to my channel. So today we're gonna do problems called House Robber 3 and just like House Robber 1 and House Robber 2, you can choose, let's say you will try to maximize the profit out of this house, which is the three nodes right here. And let's say you try to rob this house, right? You cannot rob the adjacent house at the below. You have to skip that and then you move on to these two house in the next level. You can think of that. And these two right here, if you choose to skip the root node, you move on. So you choose these two nodes. So it's 2 plus 3. It's gonna be 5. And if you choose the root node, so you have to skip this two, and you're gonna do the on the step right here. So I draw a love circle. So 3 right here. So you have 3 and 1. So 3 plus 1 is gonna be 7, right? So that is just the intuitive of this. Let's say, and then since it's a 3, you have to solve it in using DFS. And basically you're gonna use the port order. You're gonna use the pre-order traverse, just to let you know. So you have to go all the way to the left first. You go all the way to the right, right? You get these two numbers, then you return these two to back to the root. So basically the order is gonna be left root, right? Because the root right here, it needs something. So DFS. So think about when you are at the root node, right? When you're at this point, you will think you have two choices. You choose this node, right? If you choose this node, you're gonna get the left, right? It's gonna get the left and the right of this node would be the whole thing down here, right? This one, let's say I add another one is 4, right? You're gonna get all and everything in here. So, right, you're gonna get all of these in here. So plus the root. So this is the case where you choose to get the root. In the case that you choose to skip the root, right? So you skip the root, you don't have to do it, you do this one. And let me draw a circle right here. You choose the root, you choose this one. You will need to compare and skip and the root. The skip and the choose, let's call that, right? You have to see what is the maximum, right? You have to compare the maximum, not plus, my bad. You have to compare which one is the maximum chosen. But I will code that up and I will explain why it's not really efficiency. Let's code this up. So right here I have my diff, DFS, right, root. I have if not root. In the event there's nothing, I just return 0, right? So now I have to ask myself, let's say I'm gonna have choose, right? Choose is gonna be root.val, and underneath here if root.left. So if there's root.left, choose would be plus equal to the DFS, right? You have to call the children of it like grandchildren, and every node in the grandchildren. So left, and then it also needs to plus the plus the of right. And if root.right, it's gonna be the same thing, right? But this one is changed to right, and this one also changed to right, something like that. And then the other case where you choose to skip, max skip would be either, oh my bad, skip would be either the DFS of the root dot right. This is the neighbors of it, the adjacent. So if you choose it, you must not go to the path where there's the right. So when you skip it, you choose to go with the children. So left, just like so. And then at the end, you just return the max of skip and choose, right? And then we just return DFS of root, something like that. It should work. Yep, it's work. But this one is highly inefficient because you have to traverse on of, you have to traverse to this children, traverse to this from here. That's a lot. And also usually when this case happen, I will add a catch. So this is a catch. So if root in catch, right? So if root in catch, return catch of root, and then I also do the same thing down here, and I return this one. Result should be the same and substitute run, but it's not really efficient. There's another way to solve this problem where you involve a state of return. Right, so let's try to do that right here. Imagine that you must at this level, right? You need to know that when you return to the upper, right, you need to know the skip value at this point and the drop, like and a choose value, right? Skip and a choose. So what if instead just return the number? I would return the state of choose, right, and skip. And if it reached the base case, it's gonna be 0. I will return the state of it. Let's using this example. So at this point, right, I will return 0, 0 since it's new pointer. So when this return back to 1, right, it's absolutely needs to be truth. It's gonna be 1, right? Let me put this together. So it's gonna be 1 and 0 because it's take the 1 and it plus whatever in here, but we don't have that, so it's gonna be like this, right? And when this returns to 3, when you choose 3, right? If you choose the 3 right here, you will have to plus the skip of the 1, which is the 0 right here. So you take 3 plus 0 is 3. So meaning this, you choose the choosing number is 3, right? Choosing number is 3 right here. And the not choose is gonna be this plus the choose of this side, which is gonna be 0, right? So 1 right here. Same case when you go this side. You go 2, this one is 0. Same for this is gonna be 0 and another 0, another 0. So this one is return 3 and 0. So we choose 3, right? It return back here. So 3. So it's return back here. So we have, if you choose 2, you have to plus 1. If you not choose 2, you have to choose 3. Alright, so this one is gonna be 3. Oh, if you choose, my bad. So if you choose, it's gonna be 2 plus 0 is 2. If you choose 3, it's gonna be 3 right here plus 0 right here. It's gonna be 3. So 3, right? So right here you have 3, right? If you choose 3 right here, you can choose the skip value. Like you can plus the skip value, which is the 3 right here and the 1 right here. So the total is 7. Yep. And if you choose to skip the 3, you have to plus the 3 right here and 2 right here, which is the choose of these 3. So 7 is greater than 5. So since that happened, we're gonna choose 7 when we return the maximum of 7 right here. Right? So this is where, so at this root level, we're gonna send to left and right to all the way to the bottom to get us these big value. I should use another color. Why am I? To get us these value, like these two array. So when I go back up like that, it means that it's pop up, right? You send the left and the right all the way to the bottom, pop up to get these number, right? So let's do that in the code and see how it's go. So right here, let's remove this, remove all of this, remove the choose, remove the, oh, actually I don't need to remove this and remove this. So I return array. So up here, as I said, if not root, I return 0, right? And as I said, I will need to send 2 scout down to left and right. So DFS left, so root dot left to get me, this is to get me the array to do the compute, right? So the same for here, right? DFS of root dot right. So if you choose, it's gonna be the root dot val plus the skip, right? The skip of this. So it's gonna be left of 1 plus right of 1. And then if you choose to skip, you don't take the root value. You only need to take the max of left plus max of right. This one is max of left, max of right. So if you're not choosing, let me draw that again. Maybe I skip the part. So let's say this one is return 3 1. This one is 2 3, right? So you not choosing this 3, right? If you're not choosing this, you're gonna move on to this part, right? And then when you move on to this part, you can either choose this or skip it, right? So that is where you can compare. If you choose it, it's 2 or 3 or 3 or 1, whatever. So you want to get the maximum value, right? So that's why I use the max left and max right here. Since this is the array, the max will just return a greater value in that array, right? So just like that. Now just return the skip and choose and skip, right? At the end, same thing. Do a quick max right here, and let's run this, see if it's work. Whoop. Oh, this is a scriptable. Yeah, sometimes I got weird stuff, and this one run way more faster. So that should be it. And the time complexity for this approach would be O of n on a node, and the space is gonna be the height of the tree. So yep. And if you like the video, please like and subscribe, and see you soon on our next video.